Hi, welcome to the Dummy Programmer. So today we are going to solve a question called find the duplicate number. It's a medium level problem. And what it says is that given an array of integers nums containing n plus 1 integers where each integer is in the range of 1 to n inclusive, and there is only one repeated number, return this repeated number, right? So basically, if this is your array, right? It has 5 elements. The numbers range from 1 to 4, which is n minus 1. There is one and only one repeated element, and we have to return that repeated element. In this case, it is 2. So we have to return 2. And it says that you must solve the problem without modifying the array nums and only use constant space, right? So why are these details mentioned, right? In Leetcode, if you're going through a problem, pay attention to every detail that is mentioned, right? Because there's never any unnecessary detail which is mentioned. So in this case, why is it important that the numbers are 1 to n inclusive and which is less than the length of the array, right? So if there are 5 elements, the numbers themselves are from 1 to 4 only. There's a reason behind mentioning that, okay? And it also says that there is only one repeated number, right? If you think about it, if you're going to traverse this array, technically you could use a number at any index as your direction to where to go next. So for example, if you come to 0th index, the number here is 1. And so you want to go to the number at index 1. So it is, okay, let's start traversing it, right? So you have a pointer P here, right? And you start from the index 0. The number at index 0 is 1. So you move to index 1, right? And the number at index 1 is 3. So you move to 3, right? 0, 1, 2, 3. And then the number at this index is 2. So you go back to 2, right? Which is here, right? Now it says go to number at index 4. So index 4 is this one, right? Then here again we have 2, right? So again we go back to 4, and because this is at index 2, right? 0, 1, 2. Again it says go to the number at index 4. So we go to the number at index 4. And again we have 2. So it says to go back to the number at index 2. Right? Have you noticed that we have entered a loop, right? A cycle in your data structure. So any if you remember from previous videos, if you have a loop in your data structure, or if you have to detect a loop in your data structure, you can always use a fast and slow point in it. If you have not watched our previous videos, please watch them. I'll link in the description box the video where I went through the mathematics of this. Why does this work? Why using a fast and a slow pointer on a data structure with a loop is able to, first of all, detect that there is a loop. It is always also able to tell you the entry point of the loop, right? The point from which the cycle begins. So so basically that's what we're going to do. We're going to have 2 pointers, fast and slow pointers. Fast is going to move twice as fast as the slow pointer, and it's going to traverse the array such that the next number that you're going to go to is the value at current index, right? And we will see that first they're going to meet at a given point. And from the intersection point, from the meeting point, if you put the slow pointer to the beginning of the array again, right? And you keep the fast pointer at the meeting point, and then they start moving at the same pace, the next meeting point is going to be the starting point of the loop, okay? Again, there is some mathematics behind it. It's a bit mathematical. I went through the mathematics of this in a linked list video, I think, which use the same principle. Okay, so I'll link it in the description box below. Please watch it. It's very important. The solution is constant space because it only uses 2 pointers and ON, time complexity. Okay, let's code it quickly. It's a Friday and I have to go out. Okay, so we have slow pointer. Slow is equal to nums of 0, right? And then fast is equal to nums of fast, nums of nums of 0. Okay, so we have to start the loop until they meet, right? So while true, we move slow one node at a time. So this is because we are the next place that we have to go to is driven by the value at current index. The value at current index is the index that we have to go to next. So this moves one iteration at a time, slow, and fast moves 2 steps at a time, right? So nums of past. Okay, so nums of past is the next one, and the value at that index. Again, we will move that many steps forward. So this is what past becomes. If slow becomes equal to past, then we break out of this. Okay. Why are we able to do this? Because it says that there has to be a repeated number. So if there is a repeated number, we know that there is a loop. So there is no doubt that there is a loop or not. We know that there is a loop. That's why we have used this condition. So it's not going to go on forever. It's going to break because they are going to meet at some point, right? Once they have met, we put the slow pointer back to the first element. So slow becomes nums of 0. And now we are going to run this until slow becomes equal to, slow is not equal to fast. We are going to move one step forward. Slow is nums of slow, and fast is equal to fast, nums of fast. Right? And then we just return slow or fast. I mean, they're both going to be at the same point. So you could either return slow or you can return fast, right? This is the solution. Let's just go through it once. And then we move twice as fast. And then if it is equal to, yeah, I think this should work, right? Let's run it. Yes, it ran really fast. If you did not understand the mathematics of it, why do we say with so much confidence that there's going to be loop if there's a duplicate number? Please watch the video in the description box. You will understand it. There is a bit of mathematics behind it. But this is it. This is the best solution for the problem. No extra space, linear time. Thank you for watching. If you like the video, please like it. Subscribe to the channel, share with your friends, and see you in the next video. Bye-bye.